Hello, welcome back, everyone. This is Raja Manish, as you know me already. We have started with motion in a straight line in last two classes. In last class, we have seen what do you have seen? In last class, we have done few questions on distance and displacement. Okay, we have seen the general formula for displacement in the circular motion part, right? So, without any further delay, let us start with the next part. So we'll see some more questions in today's session. Okay. So two examples we have seen, and then the general formula. Okay. Well, let us see the next question now. Right. Fine. Okay. Let us read the question. Go through the question once. Fine. So the question says that a particle is moving along a straight. Sorry, a particle is moving along a circle such that it completes one revolution in 40 seconds. Then in 2 minutes and 20 seconds, we need the ratio of displacement by distance. Okay. So here, let me draw a diagram. So here the particle is moving along a circular path, and it says that the person completes one revolution, the particle completes one revolution in 40 seconds. Then we need to figure out how much will be the ratio of displacement and distance at the end of 2 minutes and 20 seconds. So first, let us figure out how many revolutions he will make in 2 minutes and 20 seconds. Since he completes one revolution in 40 seconds only, but he is moving for 2 minutes and 20 seconds. So we have to first figure out how many revolutions he will make in 2 minutes and 20 seconds. Okay. So if I see the total time that we have, the total time is 2 minutes and 20 seconds. So if I convert it into seconds, that will come 2 into 60 plus 20. Okay. So that will give us t equal to 2 into 60 becomes 120. So 120 plus 20. So the total time in seconds is a 140 second. Okay. Now, now we'll figure out that how many revolutions he'll make. We need to get an idea about his position. We need to figure out where the person will actually end up after 2 minutes and 20 seconds to get the ratio of displacement and distance. Okay. So what we'll do is we'll find the number of turns. So the number of turns will be this total time divided by the time period, the time that it takes to complete one revolution. So the total time is 140. 140 divided by 40, right? So that will become 0 gets cancelled here, and this is 7, this is 2, so 2 by 7. So number of revolutions will get 3.5. So you are getting n as 3.5, right? So these are the important results. I'm just making a box for understanding. So it got the person is going to make 3.5 revolutions in 140 seconds. So I need the ratio of displacement and distance at the end of 3.5 seconds. 3.5 revolutions. Sorry. So let us see how it moves. Let us say the person starts from this point, and he completes three. He's going to complete three compute revolutions and one half revolution, right? So if I take three compute revolutions, so after one, two, three. So after the three revolution, he will be at the same point from where he started, right? So he completes three revolutions, one, two, and three, and another half revolution. So after another half revolution, he will end up at a diametrically opposite point. So after another half revolution, he'll end up at diametrically opposite point. So this is like the final position, and this is the this is the initial position, and this is the final position, right? Now, if I draw a line joining them, so the length of this line, and the length of this line is going to be the displacement. Displacement is the shortest distance between initial and final position. So length of this line will give us displacement. Okay, right. So first let's find the displacement itself. So the magnitude of the displacement is going to be, if I take the radius of the circle as r, this will be the center here, right? And then just a moment. Okay, right. So displacement here will be equal to the length of the diameter. Okay, so displacement will come out as 2 times the radius. Okay, right. Fine, leave it. These things are in temporary. Fine. So displacement I got as 2r, and the distance. So distance, how much will be the distance here? So see, distance is the length of the total path traveled. So here the person is going to make 3.5 revolutions. So if he is making 3.5 revolutions, distance covered will become 3.5 times 2 pi r. Okay. So we can simplify this a little bit. 3.5 into 2 becomes 7. Pi is 22 by 7 into r. So distance will be equal to 22r. Fine. So how much will be the distance in this case? Distance will be equal to 22r. Now what do I need in this question? I need to find, or we need to find, the magnitude of displacement and distance, the ratio. So the ratio of the magnitude of displacement and distance will be equal to, so the magnitude of displacement is 2r and the distance is 22r. So 2r divided by 22r. So here r will get cancelled and it will become 2 by 1 by 11. Right. So this will be the answer here. Fine. So you can see for this particular question the answer will be 1 by 11. Right. Fine. So I hope this is clear. If required, you can pause the video at any instant. It's up to you. We'll go for the next one. Okay. Okay. Let us see this. Right. Now let us see this one. They're given a car starts from P. Let us see the another question. This is the fourth question. You can say example 4. Okay. They're saying a car starts from P and follows the path as shown in figure. Finally, car stops at R. Distance traveled and displacement of the car. If A is 7, B is 8, and R is 11 by 5 meter. Right. We need to find the distance traveled and the displacement of the car. So let us first find the distance traveled. We need the distance and displacement. So distance, as we all know, it is the length of the total path traveled. You know, distance is the length of the total path traveled. So how much will be the distance in this case? So let us see. So distance will be length of this path, this curved path that the particle follows. So if we add the parts, so first it goes in a straight path. So length of the straight path will be just a plus length of this curved path. So this is semicircle, right? So length of semicircle is pi r. 2 pi r by 2, that becomes pi r. So this will be equal to pi into r plus, again it goes along this path. So this length is b. So pi r plus b plus, now it goes along this path. So this is again the semicircle will be pi into r, but here the radius is 2r, because the 4r is the diameter, right? So radius will be just 2r. Fine. Right. So if you have any doubts, you can put it in the comments anyhow. So pi into 2r, right? Now let us just simplify this. They are given some values. So a is 7. So 7 plus pi into r is 11 by pi. So pi into 11 by pi plus b plus pi into 2 into r. R is again 11 by pi, right? So now if we simplify this, what will this become? So here pi gets cancelled, and b value I forgot to put. So b here is 8, right? So this pi will also get cancelled. We'll get 7 plus 11 plus 8 plus 22. So 22 plus 8 will become 30. 30 plus 18, 48, right? Sorry. So it will become 48 meter. Fine. The distance traveled in this case here will be 48 meter. Right. So the distance traveled. Okay. So the distance traveled here comes out as 48 meter. Now we need the displacement. So displacement is the shortest distance between initial and final position, right? So that should be pretty easy to find. The displacement will be equal to, yes, displacement. Displacement will be equal to length of this line. If I draw a line joining P and R, then length of this line becomes displacement. Okay. So displacement will be equal to A plus 2R plus B plus 4R, like that. This becomes the displacement here. Okay. Now you put the values. Again, the simplification could be little lengthy here, because A is 7. Now 2 times R is 11 by pi plus B is 8 plus 4 times R, so 4 times 11 by pi. So 7 plus 8, uh, right? These two we can add first. So 7 plus 8 will become 15. 7 plus 8 is 15. 15 plus 22 by pi plus 44 by pi. So that will become how much? 66 by pi. Right. So we can simplify this a little bit. We'll go 15 plus 66. Pi is 22 by 7. So 1 by pi will become 7 by 22, like that. So this gets cancelled 3 times. So this becomes 15 plus 21. Okay. So how much will be 15 plus 21? So 5 plus 1 6 and 2 plus 1 3. So 36. 36 meter will come out equal to 36 meter. Fine. So here the distance travel will be 48 meter and displacement will be 36 meter. So answer will become the first option here, right? Fine. So I hope this is clear. This is it was a simple question only. We'll go for the next one now. Right. So let us see this. Before that, let us see this one. Right. So this will be our which example? Fifth one. So this is example 5. Right. Okay, let us see. Here they are saying an aeroplane flies 400-meter north and 300-meter east and then 1200-meter upwards. Then net displacement is. So see, we can solve this question in two ways. Okay, we can solve this question in two ways. Okay, right. So what I was saying is that there are two ways to solve this question. Okay, so one method is easy. If you use the vector method, then it is easier. But if you try to do by like basic geometry and trigonometry, then it becomes difficult. Okay, so let us see. Right. So first we'll do with the method one, the first method. Okay, right. So what is the first method? Let us see. So here we can use vector. That vector method, if I use it, will be much easier. Vector you might study later in some institutes. You might have studied already. It depends. Okay. So method one, some of you might understand, some of you might not. So don't worry. So here, if I put the directions, right? So north, south, east, west, we have. So we all know that the east will be towards right, west will be towards left. This will be north, and this will be south. Now, so you can see the first. You can see first the airplane moves north, then east, and then upward. So the net displacement, है ना? So it's like it is having three displacements. So we can say that the net displacement will be vector sum of all these three displacements. S bar will be equal to S1 bar plus S2 bar plus S3 bar, like that. Fine. Now east can be taken along positive x-axis, north can be taken along positive y-axis, west along negative x, and south along negative y. Now let us put the values. So S1 bar. So first it moves 400-meter north. So 400-meter north means along y-axis, right? So I can write S1 bar as 400 j cap. Okay, I can write S1 bar as 400 j cap because north is along positive y-axis. That's how we have taken. And S2 bar. Next, it moves 300-meter east. So 300-meter east, that is towards right. So that can be taken as I cap. है ना? East is along x-axis. So S2 bar can be written as 300 I cap plus S3 bar. S3 bar, it is 1200 meter upward. So upward is like z axis. Okay, if I take an axis perpendicular to the plane like this will become like z axis. Okay, z axis is perpendicular to all these things they are mutually perpendicular axis. Z axis is like out of the plane. Fine. So vertically up is along z axis, so you can take that as 1200 k cap. Fine, it can be taken as 1200 k cap. So now overall the displacement is the displacement vector. Now what we need is the magnitude of this vector. So this is the net displacement, but in vector form. Here they have given options in terms of magnitude, not in I cap j cap notation. So displacement here will be simply the magnitude of this displacement vector. So magnitude of displacement vector will come out equal to under root of. So if you have any vector, Its magnitude is under root of I cap component square plus j cap component square plus k cap component square, like that, or j cap component square also you can start with, not an issue. So 400 square plus 300 square plus 1200 square. Okay, so 100 square, if you take common, 100 will actually come out. Okay, and if I take 100 square as common, then 100 will come out. Okay, right. So they're saying that 100 will come out. So if 100 comes out, then inside, okay, inside will be left with like 4 square plus 3 square and 12 square. So let me simplify that. So 4 square comes out as 16, 3 square will come out as 9, and 12 square will come out as 144. Right. So it will become 100 into a square root of 9 plus 6 becomes 15. 15. So it comes out as 169. Okay. You simplify this, will come out as 169. So 25. 16 plus 9 equals 25. 144 plus 25, 169. So this becomes 100 into 13. So basically 1300. Okay. So this will become the displacement here. Okay. So this will become the displacement. This only will be the answer in this case. Right. Fine. I hope this is clear. So answer here will be 1300 meter. Okay. Now suppose if you don't know the concept of vector. Okay. If you don't know the concept of vector, then how to do it. Okay. Method 2, let us see. The method 2 is little difficult to comprehend or to understand, you can say. Okay, let us see the second method. In second method, what is happening? The airplane flies 400-meter north. So let us just draw the displacement vectors. Okay. So first the airplane moves 400-meter north, right? Okay, not an issue. Fine. Okay, right. So first it moves 400-meter north, like this. Then it moves 300-meter east. So 300-meter that it is moving will be something like this. So this is 300-meter. Okay, let me draw slightly longer, so that it will be in line with the vector idea. Okay, means the length represents the magnitude. So 300-meter is towards right. Now he is going right. So you need to understand that now he is going for 1200-meter up. 1200-meter up means out of the plane. Okay, it is going 1200-meter up. That means it is going out of the plane direction. Fine. Now how to handle that part, out of the plane situation? So see, out of the plane will be like vertically upward. Now if I mark some points here, like this is A, this is B, and this point is C. Now displacement is not AC. Okay, it is going out of the plane somewhere up in upward direction. It's not at certain angle. It is out of the plane in a completely different direction. Z axis altogether. You have to imagine up. Okay, so to connect C to that point. So first what I'll do is let me draw a line joining A and C. Okay, this is not the displacement, but this is an intermediate value that I have to find. So A, and if I join A and C, the length of this line A and C will become under root of 400 square plus 300 square. that will come out equal to under root of will be equal to under root of 500 square plus 1200 square. Okay, and that we have calculated earlier, that comes out equal like 100 you can take common, and under root of 169 will be there, and it comes out as 1300. So the required displacement, okay, the required displacement will be the length of this line AD. Okay. The required displacement will be equal to the length of this line AD, right? Fine. So magnitude wise displacement will come out equal to 1300 meter. So this becomes the answer here. Okay, right. So you can understand from both the methods we get the answer as 1300 meter only, right? Okay. You can scroll up and see if you need any doubt, if you have any doubt. Okay. Now one last question will do. Now this is a different kind of question. Means not very different, similar to this previous one. Okay. Right. So we have around 4 minutes. We'll try to do it. Now this one is much easier if you do it in vector form only. Okay. The other method is very confusing. You cannot really come to a conclusion if you use the second method. Okay. Anyhow, let's do it the first method quickly. So method one. They're saying a person moves 30-meter north. And when the problem is happening. Okay, right. So a person moves 30-meter north. So how the person moves is he moves First he moves 30 meter north, so that is in upper direction. Okay. Then 20 meter east. Then 30 root 2 meter southwest. So 30 root 2 southwest means exactly between south and west. Okay, when they say southwest, means exactly between south and west means at 45 degree. Okay, so this angle will be 45 degree. Fine, southwest means exactly between south and west, so this angle will be equal to 45 degree, right? Now this length is 30 meter, this length is 20 meter. Now this is 30 root 2. Now many of you might just join these 2 points. You know, if you're trying to do like this, many of you might join these 2 points. You may not be able to figure out that will cut exactly here. Fine. So this is 20. If this is 45 degree. This is perpendicular, right? So if this is 20. This is 45. This will also be 45 because this is 90. So this length actually comes out as 20, and then he actually ends up here. Now this is very complicated if I try to do it with this geometric method. Geometrically, if you try to analyze, it will start from A and it will actually end at B. Fine. Now figuring that out is a little difficult geometrically, so we'll do it in vector form directly. Okay. So see, the net displacement vector will be the sum of three displacements: s1 bar plus s2 bar plus s3 bar. Okay. Right. Just give me a moment. Just a moment. Right. Fine. So I hope you understand now. The point here is that the net displacement. Okay. So net displacement will be the vector sum of all these three displacements. First it goes north, then 20 meter east, then 30 root 2 meter southwest. So the point is, like, analyzing geometrically is very difficult because you being able to figure out that will start from here and will end up here is difficult. Okay. So net displacement will be vector sum of these three. Now let us add all these displacements in vector form. So see, S1 bar is very simple. Again, you can take the x-axis and y-axis accordingly, so you can understand in general. If I draw it like this, so this is north, this is south, this is east, and this is west, right? So east we take positive x-axis and north we take along positive y-axis. Now the first displacement is s1 bar is 30 meter north, so that becomes 30 j cap. Then s2 bar is 20 meter east, so that becomes plus 20 I cap. Then s3 bar is 30 root 2 meter southwest. Okay, so 30 root 2 meter southwest. How exactly we write it in vector form? For that, I'll just, for now I'll just keep it as s3. So s3 bar. Okay, we'll calculate s3 bar separately. Now you look at s3 bar. So s3 bar is 32 root 2 meter southwest. So exactly between south and west. Okay, exactly like along this direction. Exactly in between means it will be making an angle of 45 degree with south direction or west direction. With y-axis it will make an angle of 45 degree, you can say like this. Or you can take this angle also as 45 degree, no problem, anything. So this length, the length of this vector is 30 root 2 meter, right? So what is going to happen now is that it will have two components. One component will be towards left like this, and one component will be in vertically downward direction like this. Okay, so this length will be 30 root 2 cos 45 degree. Cos 45 degree is 1 by root 2. So 30 root 2 into 1 by root 2, that will become 30. So it will have a component of magnitude 30 towards left, and this one becomes 30 root 2 sine 45 degree. Okay, this one is cos 30 root 2 sine 45 degree. So it becomes 30 root 2 into 1 by root 2. So that will also become 30. So you can see the third displacement is having 30 component along west and 30 along south, means along negative x-axis and negative y-axis, you can say. So we can write S3 bar. S3 bar will become minus 30 I cap minus 30 j cap. This will be S3 bar. Okay, we can take this as equation 2. Right. Now if we use equation 2 in 1, in that case the overall displacement vector S bar will become 30 j cap plus 20 I cap minus 30 I cap minus 30 j cap. Right. Now simplify this. S bar. So this j cap part will get cancelled. 20 I cap minus 30 I cap. So that will become minus 10 I cap. Okay. So we got displacement vector as minus 10 I cap. So minus 10 I cap means the overall displacement will be 10 meter. Minus I cap is along west direction. 10 meter west. So from the initial position it will end up at a point which is 10 meter to the west, like this. So this is how the final displacement vector will look like. Okay, right. So as I was saying, finally the displacement vector can be written as let me write it in vector form only. 10 meter west. So from initial position it will end up at a point which is 10 meter west. So this becomes the answer here. Okay. So 10 meter west. This is the answer. Now this is with the displace like in vector form. And if you try to do geometrically, which I actually did try doing here. Now if you try to do it geometrically, it is a little difficult. Let us see. So if I use the second method, if I try to do it geometrically, okay, with the help of trigonometry. So the person first goes 30 meter north like this, then he goes 20 meter to the east. Okay, so this complete length is 30 meter, this length is 20 meter. Now 30 root 2 meter southwest. So you need to understand that southwest means exactly between south and west. Fine. So this angle will be 45 degree and this will be 90 degree. So and so you know that sum should be 180 degree. So this is 45 degree, this will come out as 45 degree. So the point is that this line, this will be an isosceles right angle triangle, and this triangle that we have here, this one will be an isosceles right angle triangle. So if this length is 20 meter, this length from here to here will also be 20 meter. So you can see the length from here to here, then this length will become how much? Square root of 20 square plus 20 square, so this will become 20 root 2. Now this complete length, see the complete displacement is 30 root 2 meter. Okay, 30 root 2 meter. Now you see, if this complete length is 30 root 2 meter, if this length is 20 root 2, this length till here, this length will be 30 root 2 minus 20 root 2, so that becomes 10 root 2. And this length will be 10. Total is 30, if this is 20, this will be 10. So the person starts here and he will end up somewhere here. Now we need this length. Okay. So you can see this angle is 45 degree. This angle will also be 45 degree. Okay. And now you have to understand that this will actually be a right angle triangle because this is 10 root 2 cos 45 is 10 only. So this should be a right angle triangle and this angle will also be 45 degree. Means this is where slight complication might come. Like how will you have to prove that this will be a right angle triangle because 10 root 2 cos 45 is 10 and this length is exactly equal to 10 means it should form a right angle triangle. So again you can see this will become like isosceles right angle triangle. So this length is 10 meter, this length will also be 10 meter. So finally the displacement vector, the purple line represents the displacement vector. So the displacement you can see it is starting from point A and it will end up at point B, which is like to the left or to the west. So you can say that the displacement here will be 10 meter west. Okay, displacement here will be 10 meter west. So this that becomes the answer here. Okay, right. Okay, students, I hope you understood this one. The method 2 is slightly complicated, especially the last bit. Okay, you have to prove that this will be a right angle triangle, and then you can say that the displacement will be 10 meter. But the first method is very simple. Once you study vector, you can do it easily. Okay, fine. So I'll keep it till here for today. We'll continue this in the next class. So we have done a good amount of questions on distance and displacement. So now we'll start with the average speed. Okay, so we'll start with average speed and average velocity part. So mostly the average speed part in the next video. Okay, so until then, keep learning. Thank you for watching. Okay, do consider subscribing if you like the videos, if you like the content. Okay, thank you.